f times g of x, which is the same thing as f of x times g of x. So in our case, we just need to multiply the x squared plus 4 by 7 minus x. When you FOIL that out, 7x squared minus x to the third plus 28. 4 times negative x is minus 4x. And all of these are unlike terms, so this is where you have to leave your answer. Number 2, we have f of g of negative 2. So we're going to figure out what g of negative 2 is first. Our g function is x squared plus 3. So g of negative 2 would be negative 2x, or sorry, negative 2 squared plus 3. Negative 2 squared is 4 plus 3, which would be 7. So g of negative 2 means when you use the g function, put negative 2 in for x, you get 7 as your answer. So you take that answer, replaces the g of negative 2. So instead of f of g of negative 2, we know negative g of negative 2 is 7. We're now trying to find f of 7. The f function is x minus 5, so this will be 7 minus 5, which would be 2. Number 3 is not multiplication, it's an open circle. Which means we're going to put the g function into the f function. That means the same thing as this. Except we don't have an actual number to put in for x. We're just going to put the function in for x and get a new formula. So the g function is x squared minus 3. So we're basically having f of x squared minus 3. Because that is the g function. So we use the f function. And where we used to have an x, this will be our input value, x squared minus 3. And then the plus 5. We evaluate that, simplify that, that becomes 2x squared minus 6. 5. 2x squared minus 1 is the composite of the two functions. You put the g function into the f function. That was number 3. Number 4, we want to find the inverse of f of x, 5x plus 10. If instead of calling it f of x equals, we call it y equals, then our inverse would be x equals, and y where the x used to be. And if we solve this for y to get it back into a form like the other one was, we would need to subtract 2 from both sides. We get x minus 2 equals 5y. Then divide both sides by 5. You have to divide the entire thing. Wait, that's not a 2, that's supposed to be a 10. Where'd that 2 come from? Minus 10, x minus 10 equals 5y. We have to divide the whole thing by 5. Some of you just divided the 10 by 5 or just the x and didn't do the both. So you can either leave it like that, or where the whole thing gets divided by 5, or you can take each piece and divide it by 5 and get x over 5 minus 10 over 5, which is 2. We call that the inverse of the f function. Number 5, we would do the same way. We have f of x equals 5x minus 3. and we want to see if x plus 3 over 5 is its inverse. So if we just find the inverse of this and see if it's the same, switch them around, solve this one for y, add 3, and divide both sides by 5, we get x plus 3 over 5, which is what they asked about. And yes, so yes, no, they are inverses. Number 6, most of you got number 6 right. Some of you didn't do the domain and range, but everybody was able to put it in the calculator pretty much and graph it. Your domain should have been x greater than or equal to 4. The range should have been y values greater than or equal to 0. You would have had points at 4, 0, and 6, 2, and then it kind of straight off from there. Number 7. You didn't make it dotted. That's what I was fixing to say on number 7. It's a less than, so it should have been dotted, shade below. Y less than is always dotted and shade below. Y greater than is always dotted and shade above. Less than or equal to's and greater than or equal to's are solid. Number 8. Square root of 4 over square root of 49. 4 over 49 does not reduce. They are not both divisible by any one thing. But if you put them in their own radical, then the square root of 4 is 2, and the square root of 49 is 7. You get 2 7s. If it's multiplication or division, you can put them all under 1, or you can give them each their own. Doesn't matter. Whichever one helps you get the problem done. So number 9, that same kind of deal can apply. If you got square root of 49, x to the 6th, y to the 4th, all multiplication, all under one radical. You can actually give them each their own to help you see what the answer might be. Square root of 49 is 7. Square root of x to the 6th would be x to the 3rd. Square root of y to the 4th, y to the 2nd. Now, why is it x to the 3rd? Well, you want to write it in exponential form. This would be x to the 6 over 2 power. This would be y to the 4 over 2 power. 6 divided by 2 is 3. 4 divided by 2 is 2. The only other thing that technically we should have is the absolute value bars around that, since that's an odd exponent and that was an even index, but I didn't worry about that. Number 10, you have a cube root this time. Now, 24 is not a perfect cube, but it has a factor that is. It has 8. 24 is 8 times 3. And 8 is 2 to the 3rd. B to the 5th. 5 is not divisible by 3, so I need to break that up into 2 pieces. One piece that is divisible by 3, and one piece that would be what's left over. So if I say, okay, that's b to the 3rd times b squared, that's the same as having a b to the 5th, but part of it is divisible by 3, so part of it can get broken out from underneath the radical. So then this piece has an exponent divisible by 3. This piece has an exponent divisible by 3. This piece has an exponent divisible by 3. So all three of those things will get broken out from underneath the radical. So cube root of 2 to the third is just 2. Cube root of a to the 6th is just a squared. And cube root of b to the third is just b. And then you have left over underneath the cube root 3 and the b squared. Number 11. Some of y'all started to do this right, but then you really didn't take out the biggest perfect square from 72 and 288. 5 square root of 72 plus square root of 75 square root of 288. Biggest square root you've got in 72 is 36. So we write that as 36 times 2. 25 is a perfect square that goes into 75, so 25 times 3. 288, you may not know the 144 is a perfect square. Hopefully now you do, and now you remember. So this is 5. And I'm going to skip a step. Square root of 36 is 6. So this becomes that. The 36 gets broken out from underneath the radical as its square root. The 36 is 6 squared. So the square on the 6 and the square root cancel each other out. And I need to multiply those things together. This becomes 5 square root of 3. 144 is 12 squared, so it comes out as 12. Square root of 2. So here I have 30 square root of 2, 5 square root of 3, and minus 12 square root of 2. The only types that you can put together are those that have the same radical. So these two, a 30 minus 12 would be a 18 square root of 2, and then the 5 square root of 3 will stay as a separate term. Stay with me there. Okay, let's go to the back. Diameter of a tree in inches is related to its base area, which is in square feet. The diameter is what we're trying to find out when the base area is 12.4. When you put it in the calculator, you've got square root of 576 times 12.4 divided by one thing, pi. And they tell us to use 3.14. So when you put that in the calculator, and you do what they say by rounding to the nearest, or rounding to 3 decimal places, you get 47.693 feet. Right, inches. Diameter, inches. It is in feet when the area is in square feet, but we are looking for, the diameter would be in inches. Alright, write the radical fifth root of 32 into the third using rational exponents. So fifth root of 32 we'll get into the third. One thing that I noticed is a lot of y'all put the 32 out without, you just took the fifth root off of it. You're trying to find the fifth root of 32 and the fifth root of m to the third. So if anything, you should do this before you put it into exponential form. The fifth root of 32 is 2 to the fifth. So what you have here, if you change this into exponential form, is 2 to the 5 over 5 power times m to the 3 over 5 power. 5 over 5 is just 1. You can get rid of that. Close the gap here. That's your answer. You got x divided by x to the half times x to the third. Now, there's a lot of ways to go about doing this problem. When do you want to move it to the numerator? When do you want to make the exponents negative? I would suggest just making these two, putting these two together by adding their exponents together. X to the half times x to the third is going to be x to the half plus a third power. What is a half plus a third? That's 3 6 and 2 6, 5 6. Okay. And then this one has an exponent of 1. We don't write it, but it's implied to be a 1. And so when you're dividing, just like when you're multiplying, you add. When you're dividing, you subtract the exponents. 1 minus 5 6 will be 1 6, aka 6th root of x. Either one. Number 15, we need to solve. Cube root 3m plus 1 equals 4. On the left side, we have only the radical. So to get rid of the radical, we need a cube. Since it's a cube root, we have to cube both sides. That will cancel the cube root and leave me with just the 3m plus 1. 4 to the third is 64 maybe. And then I start to solve for m. Subtract 1 from both sides. 3m equals 63. Divide both sides by 3. M is 21. Next one we have 4 minus a square root 5y minus 10 less than or equal to a -1. So a couple weird things have to happen here. We subtract 4 from both sides. We know we got to do that first. So we're left with a negative square root of 5y minus 10 less than or equal to -5. Now what we should do next is get rid of that negative in front of the radical. So that we have just the radical on one side, no extra stuff. So if we divide through by -1 to get rid of that thing, great. But you got to remember to reverse your inequality, which a lot of you didn't do. Then we can square both sides. 5y minus 10 is 25. I'll go over here. Not equal, greater than or equal. Add the 10. Greater than or equal to 35. 5 by 5. So some of you had less than or equal to, and I figure you just didn't reverse the inequality. Some of you had a -7, and I'm not sure what you did, but so I just left off or added a, got your signs off. All right, 17. 17 is tricky. There's a lot of wording there, and you have to make sure you read the whole sentence through. It wants to know what the velocity, says what velocity must a coaster have at the top of a 150-foot hill to achieve a velocity of 100 feet per second. So in this formula, the v sub 0 is the velocity it has at the top of the hill, at the beginning. The v underneath the radical is the velocity it'll have at the end. So v sub 0 equals square root v squared minus 64h. Then that 150 is going to be our height. What velocity must it have at the top of the hill? That means this is going to be our unknown. And that's going to be nicer than if this was our unknown. All we have to do is plug in the 100 here. So basically, we're just solving 100 squared minus 64 times 150. Get the square root of all that. Ends up coming out exactly 20. So that means it would need to start out at 20 feet per second. It needs to be moving at a velocity of about 20 feet per second if it's going to achieve that much velocity when it gets to the bottom of the hill. Number 18, square root of 34 divided by square root of 51. Well, it's kind of tricky because it's not real obvious that both of these are divisible by 17. If each is under its own radical, then they can all be under the same radical. Which would let the 17s reduce each other off. So we're basically left with square root of 2 over 3. But we can't have a radical in the denominator. So to rationalize the denominator, we got to multiply by 1 in the form of square root of 3 over 3. Square root of 3 over square root. Which gives me square root of 6 over square root of 3 times square root of 3 is square root of 3 squared, or just plain old 3. But we can leave it like that. This is correct, but it's not properly complete or simplified. Some of us forgot the formula for the area of a triangle. 6r to the half, t to the 3/4. The formula for the area of a triangle is what? Base height divided by 2. So in this case, our base, 6r to the half, t to the 3/4, times 8, r to the half, quarter, all divided by 2. So as we simplify this, 6 times 8 is 48. R to the half times R to the half. A half plus a half is a whole, so we're just left with plain old R to the first. T to the 3/4 times T to the 3/4. We add the 3/4 together, we get 6/4, also known as 3/4, 6/4, 3 halves over 2. That would be fine. Three-fourths plus 3/4 is 6/4, which reduces to 3 halves, in case you didn't realize where that came from. And then the radius of the sphere has a volume of 66 cubic centimeters. What's the radius? Okay, 3 times the volume of 66 over 4 pi. Now, it doesn't say we can use 3.14 for pi now, but it did earlier. So we can go ahead and just keep using 3.14 for pi. We take it all to the 1/3 power. In other words, we're taking the cube root of it all. We put that in our calculator and take the cube root of it all. We get 2.5 centimeters. You have to make sure you put it in the calculator correct. So when you put that in there, you take the cube root of, when you're writing it in, you may want to do 3 times 66 divide by, and then you probably need to put the whole denominator in parentheses, 4 pi. Because if you don't, it'll divide by the 4, but then it'll turn around and multiply by pi instead of dividing by pi also. So that could have messed you up. Or you can do it piece by piece. Plug this in the calculator, get a number. Plug that in the calculator, get a number. Divide them, then take the cube root of the whole thing. Whatever, but the order of operations prevail. And then the bonus. G of x is equal to g of x. Find x. Okay? G of x is 5x minus 8. So 5x minus 8, or minus 8, is equal to the 5x minus 8. This is putting g of x into g of x, setting it equal to g of x. And then we go find x. 5 times 5 is 25x. 8 times 5 is 40. Minus 8 equals 5x minus 8. Combine our like terms. Minus 48, 5x minus 8. Get all the x stuff on the same side, all the constant stuff on the same side, so we need to subtract off that guy from both sides. That leaves us with a 20x. Add the 48. And it leaves us with just plain old 40 on the right. And divide by the 20 to leave us with a nice, even value of 2. X should be 2. All right.